Okay, so let's take our frequency table that we've created now and turn it into a relative frequency table. And as a reminder, relative frequency just means percentages. So if I wanted to do this by hand or with just a calculator, I would have to say that there is one number 9 out of 28 total data values, because I could add this all up and I would see that there are 28 different numbers. And dividing that out, I actually already did that on my calculator here. That gives me 0.0357, and you can do that as well to double check. And then I would have to say something like there are 4 11s out of 28 total data values, and if I divide that out, I get 0.1429. Right, so it's like there are 3.57%, I could say, nines, and there are 14.29% of people of these goals scored were 11s. Now I would have to divide every single one of these out. So again, that becomes very cumbersome if you've got a lot of data. So how can we do this in Excel and make that a lot easier on ourselves? So if I'm going to go ahead and minimize that. So here are our directions for how to create a relative frequency table in Excel. So I'm going to start by labeling my next column relative frequency. And what we're going to do is we're going to type in equals and then start with the first cell. So in our case, it's equals C2. And then we're going to divide that by the sum, because again, we're doing, the dividing by the total. And what you want to do in this case is highlight the entire column that you are finding your sum of. Do the whole thing, highlight it by its letter up here, and hit enter. So I can see that that was the same as that first value that we got when we did it by hand. Now let's click and drag that all the way down, and in doing that I can see that this second value was also the same as what we got, and we could go ahead and copy down all the rest of those values if we want to. So we can now see that this next one is also 0.0357. The next one is 0.1786, let's say, 0.1071, 0.0714, and a lot of these are the same. So this is another 0.1429, 0.0714 for a lot of these in a row. And these last two are 0.0357s again. Okay, this is advice that I find to be very helpful to make sure that you have not made a mistake, that you didn't accidentally type the wrong formula somewhere and these values are off. What's always a good idea is to go below these relative frequencies and do a check. All your percentages should add up to 100%, the total, or it should equal 1 in this case since we're in that decimal formatting. So I'm going to say equals sum, and then I'm going to highlight all of these relative frequencies. So when I add all those together, I better get 1 as my answer. And as long as I get 1 as my answer, I'm feeling pretty confident that I've done everything correctly, like that I've typed in all the formulas correctly and that everything's worked out. So I'm feeling good about that right now. I'm feeling good about everything that I've got answered over here. Let's go ahead and answer this last question then. It says, what percentage of these players scored more than 20 goals? So more than 20 would be 21 or 35. Those are the only different goals we have that are strictly more than 20. So now I can answer that fairly easily, that I've got all my percentages here. I could just say, well, there's 0.0357 for the 21 and a 0.0357 for the 35, and we could add those together, and added together that's the same as 2, so that's 0.0714, or we could say about 7.14% of the players scored more than 20 goals. So now we can start answering some of those more in-depth analysis type questions that I definitely would not have been able to answer very quickly by just looking at this list of numbers. Once you've got your frequencies and your relative frequencies all in a nice table in a nice format, then you can really dig into these kind of more in-depth things and see your patterns and just really get down to the meat of things.